So in this episode, you will learn about reflexive relations, symmetric relation, and transitive relation. Now, what's a reflexive relation? The word reflexive is derived from English word reflection, which means the image of itself. So, if an object has got some relation with itself, we say it is a reflexive relation. So, a relation R on a set A is said to be reflexive if every element of A is related to itself. Hence, R is reflexive if and only the set of A and A belongs to R for all A which belongs to set A. Now, let's try to understand reflexive relation with an example. Let A is equal to A, B and C. Now the relation R is equal to AA, BB, CC, CA and BC. Is this a reflexive relation? Let's check it. Here you can see A is related to A, B is related to B and C is related to C. So all elements are related to itself. Hence, this is a reflexive relation. Let's try another relation R1, where R1 is equal to AA, BC, CC and CA. Here you can see B is present in set A, but we don't have any combination BB in our given relation R1. Hence, B belong to set A, but the combination BB doesn't belong to given relation R1. Hence, R1 is not a reflexive relation. Now let's do one more example. Let L be the set of all lines in a play, then the relation R on L defined by L1 L2 belongs to R if and only L1 is parallel to L2 is reflexive. Now you know it very well that every line is parallel to itself. Hence, for any line L1 which is in given plane L, you can see it will be parallel to itself. So the given relation R is a reflexive relation. Now let's try one more example. The relation R being the same height as is a reflexive relation. Now suppose we talk about anything, say a person or an object, and we say the person has got the same height as that of the person. So that is a valid universal statement. So everything has got the same height as itself. So R is a reflexive relation. Now what's a symmetric relation? A relation R on a set A is said to be symmetric if and only AB belongs to R, then that means BA also belongs to R for all value of A and B which belongs to A. That means if A is related to B, then that also means B is related to A for all value of A and B which belongs to A. And now, when do we say that a relation is not symmetric? A relation R on a set A is not a symmetric relation if there are at least two elements x and y which belong to set A such that xy belongs to R but yx doesn't belong to R. Now let's take an example. The identity relation on a non-wide set is symmetric. Now what's an identity relation? Remember, the relation IA is equal to the set of all A and A such that A belongs to A is called identity relation on A. Now here you can see if we change the position of A with A, so the relation will remain same. So it's clear the identity relation on a non-wide set is also symmetric. Now let's take one more example. Let R be a relation defined on L where L is the set of all lines in a plane which are perpendicular to each other. And R is defined as R is equal to the set of all A and B such that A is perpendicular to B, where A and B are lines on a plane. Now here you can see L1 is perpendicular to L2, which is given. Now since L1 is perpendicular to L2, that means L2 is also perpendicular to L1. So if L1 and L2 belongs to R, then that also means L2, L1 also belongs to R. Therefore, R is a symmetric relation. Now, what's a transitive relation? A relation R on a set A is said to be transitive if and only AB belongs to R and BC belongs to R, then that also implies AC belongs to R for all A, B and C which belongs to A. That means if A is related to B and B is related to C, then that also means A is also related to C for all A, B and C which belongs to set A. Now let's understand this with an example. The relation R on the set N of all natural numbers defined by AB belongs to R if and only A divides B for all A and B belongs to natural number is transitive. Now suppose ABC belongs to N, where AB belongs to relation R and BC belongs to relation R. And now AB belongs to R. That means A divides B, or B is equal to M into A, where M is a natural number. Also, BC belongs to R. That means B divides C. Or we can say C is equal to N into B, where N is a natural number. Now C is equal to N into B. C is equal to NB. Now as C is equal to NB, or we can write C is equal to N into M into A, because B is equal to MA. Or we can write C is equal to Mn into A. Hence that also means A divides C. So that implies AC is also related, or AC belongs to R. Hence, if AB belongs to R and BC belongs to R, then that also implies AC also belongs to R for all A, B and C which belongs to natural number. So, the given relation R is a transitive relation. Now let's do one more example. The relation is parallel to on L, where L is the set of all straight lines in a plane, is a transitive relation. Suppose we have got three lines L1, L2, L3 which belongs to L in a plane, where L is the set of all straight lines in a plane. Now if L1 is parallel to L2 and L2 is parallel to L3, that also means L1 is also parallel to L3. Now that means this is a transitive relation, or the relation is parallel to on L, where L is the set of all straight lines in a plane, is a transitive relation.